Hello, here we go. 4.3. Factoring. This is definitely a review. So how do we factor? And we're going to talk about how we solve a quadratic by factoring. So always, every time you're factoring or solving by factoring, please look out for that GCF first. Remember, GCF is greatest common factor. So if everything is divisible by 2 or 3 or 10 or whatever, go ahead and divide it out. That is going to make your life a lot easier. So always look for that GCF first. If A is equal to 1, so if it's in that standard form and A is equal to 1, keep it simple. You guys know this. It's, maybe used X factor or whatever, but essentially you're finding the product of A and C. And if A is always 1, then it's just C. And you want to find factors of that number that add up to that middle term, which is B. Remember, it's the same thing when A is not 1. That's what we had some practice on last week. And so we'll review that. But you do also have two special types of factoring, and that is the difference of squares and a perfect square trinomial. So a difference of squares is exactly what it sounds like. You are going to be subtracting two perfect squares. So it's really important that you recognize your perfect squares: 1, 4, 9, 16, 25, 36, 49, 81, etc., etc. You really should know all the way up to 15 squared, which is 225. But if you at least know up to 100 or that 121, it'll make your life just so much easier. So the way that we factor a difference of squares is you're just going to take the root of the first term, the root of the last term, and you'll have one negative and one positive binomial there. So A plus B times A minus V, or vice versa. And then a perfect square trinomial is when you see a perfect square in the beginning and a perfect square at the end, and that middle term is 2 times the square root of the first and the square root of the last. And then whatever sign is there will depict what sign you use in that binomial squared. Okay. And then, of course, like I said, factoring when your A value is greater than 1. Again, you're multiplying that A and C value. You need factors of that number that add up to the B value. We rewrite that middle term, and then we factor by grouping. So we look at the first two terms, we look at the last two terms, and then put it all together. So hopefully working some examples will have it come back to you. So here we go. Let's go ahead and start. First things first, we always want to look out for that GCF. So in part A, there is no GCF between 49x squared and 64. But what I do notice about those two terms is that they are both perfect squares. So this is a difference of squares. So what I'm going to do is I'm going to take the square root of the first term and the square root of the last term, and I'm going to have 1 plus, and I'm going to have 1 as a minus. And it doesn't matter the order that you write these. If you want to switch those around, that's totally fine. And then I just want to double check, is there anything else I can do with these two factors? And I cannot, so this is my final answer. And that's it. Okay, so let's look at the second problem. It says 50x squared minus 32y squared, GCF. I do have 1. There is a GCF of 2, leaving you with 25x squared minus 16y squared. And so now I'm looking inside those parentheses, and I notice, again, that is a difference of squares. 25x squared is a perfect square. 16y squared is also a perfect square. So to factor that, I'm going to take the square root of the first, the square root of the last. I'll do 1 positive and 1 negative. I cannot factor any further, so there's my final answer. X to the 4th minus 16. X to the 4th is a perfect square. It is x squared squared. Remember, x squared squared is really just x squared times x squared, which you know is x to the 4th. So we can take the root of the first and the root of the last. We'll have 1 positive and 1 negative. But I don't want to stop here, because when I look at one of those factors, I have another difference of squares. X squared minus 4 is another difference of squares. Not x squared plus 4, but x x squared minus 4 does give me that x plus 2 and x minus 2. And so now I am done. D, I do see another difference of squares. So I see something squared minus 81. Well, something squared is a perfect square, and then 81 is a perfect square. So the square root of c plus d squared is c plus d. And then I have the plus 9 and the minus 9. And again, there's my final answer. Okay, let's look at E. E definitely has a GCF. GCF doesn't just apply to numbers, it also applies to variables. So notice in this, I have a 10x to the fourth, oh my god, sorry, minus 25x to the seventh. My GCF is not only 5, but it's also x to the fourth. Both of those terms have at least x to the fourth. So when I take out a 5x to the fourth, I'm left with 2 minus 5x to the third. Remember when we divide things with exponents, we subtract the exponents? So I'm technically taking x to the seventh and dividing by x to the fourth, which is just going to be x to the third, subtracting the exponents. Now, when I look inside the parentheses, there's nothing left that I can do. So this is completely factored. Okay, so I think we're kind of done with the difference of squares. All those really had that in common. When I look at F, obviously it's not a difference of squares. First thing I still want to look out for is a GCF, which of course I do have. They're all divisible by 3. So I take that 3 out. I'm left with x squared minus 2x minus 10. Okay, and so I need to look inside those parentheses and see if I can factor it. So this one has an a value of 1. So do I have factors of negative 10 that add up to a negative 2? Well, factors of negative 10 could be 1 and 10 and 2 and 5. And there's no way, oh my God, sorry. There's no way that we can make one of those negative and get a sum of negative 2. So that inside is just not factorable. So this is actually our final answer. We will learn later on in this unit how to solve that quadratic because it's not factorable. We could use completing a square or quadratic formula or whatever, but right now it's not factorable. And so we move on. Okay, G may look very, very ugly to you. You have to take it piece by piece. Remember, our first step is GCF. So let's look at a GCF between the numbers, and then let's look at the GCF between the variables. So if I look at the numbers, I have a 3, a negative 9, and a positive 12. Well, the GCF there is 3. If I look at the variables, do they all have an A? Yes. And what is the lowest exponent on our A's? 3. So I can take out a to the third from all of those terms. All of them also have a b, and the lowest exponent is 2. So I can take out a b squared from all of those terms. And they all have a c, and the lowest exponent of the c term is 1. So I can only take out one c term. What does that leave me with? Well, if I divide 3 by 3, I get 1. A cubed divided by a cubed is also 1. B to the 7th divided by b squared is b to the 5th. And then c to the 5th divided by c is c to the 4th. Negative 9 divided by 3 is negative 3. A to the 5th divided by a cubed is a squared. B cubed divided by b squared is b. And c to the 4th divided by c is c cubed. 12 divided by 3 is 4. A to the 7th divided by a cubed is a to the 4th. B squared divided by b squared is 1. And c divided by c is also 1. I do not have to put those ones there. And so then that is completely factored as well. GCF, 4, and they all have an x. And so now I have 4x times x squared minus 4x plus 4. When I look at the trinomial inside of the parentheses, I notice that my first term is a perfect square and my last term is a perfect square. This is a perfect square trinomial because the middle term is 2 times the root of the first times the root of the last. The root of my first term is x. The root of my last term is 2. 2 times x times 2 does give me 4x. Because it's a minus, I'm going to factor that as x minus 2 squared. And then you could always check yourself. What's x minus 2 times x minus 2? First times first, outer, inner, last, and there's my perfect square trinomial. If this would have been a plus 4, then that would have been positive, and that would have been positive, and so it would have been x plus 2 squared. You always take this sign. Okay, and then that's it. I cannot factor that any further. Let's try it again. When I look at 9x squared minus 12x plus 4, there is no GCF, but 9x squared is a perfect square and 4 is a perfect square. The root of 9x squared is 3x. The root of 4 is 2. And so does 3x times 2 times 2 give me a 12x? And yes, it does. Remember, the middle term is always 2. Oh, man. There we go. Is always 2 times a times b. So the square root times 2. All right, so be careful with that. So is 2 times 3x times 2 equal to 12x? Yes, it is. And so I know this is a perfect square trinomial. So to factor that, I take the root of the first, the root of the last, and the sign of the middle. And voila. And again, you could always check yourself. 81x squared minus 36x plus 4. No GCF. I see a perfect square in the front. I see a perfect square in the back. Root. 9 times 2 is 18 times another 2 does give me 36. So this is a perfect square. Minus in the middle because that's the sign. Boom. Call it a day. Yes, I know I'm going kind of fast. This is stuff that you should already know. 3x squared minus 10x plus 8. No GCF. Not a perfect square trinomial. So I just need a factor. My a value is not 1. So I'm going to multiply. 3 times 8. 3 times 8 is 24. I need factors of 24 that are going to add up to a negative 10. And so that's going to be a negative 6 and a negative 4. And so I'm going to rewrite that middle term. Remember, it does not matter the order that you rewrite it in. And then I'm going to factor by grouping. So the GCF in the first two terms is 3x, leaving me with x minus 2. The GCF in the last two terms is going to be a minus 4, leaving me with x minus 2. So I have 3x minus 4 and an x minus 2. Boom, done. We did this in class the other day. Okay, for that factoring coloring activity. Let's try it again. 2x to the fourth minus 5x squared minus 12. Is there GCF? No. Is it a perfect square trinomial? No. So I need to try to factor a times c, negative 24. Factors of negative 24 that add up to negative 5. That is going to be negative 8 and positive 3. Rewrite. 2x to the fourth minus 8x squared plus 3x squared minus 12. GCF of the first two, GCF of the last two. The first two have a GCF of 2x squared, leaving me with x squared minus 4. Hint, hint, wink, wink, nudge, nudge. And then I have a GCF of the last two terms of a positive 3, leaving me with x squared minus 4. So my factors are 2x squared plus 3 and an x squared minus 4. I cannot call that my final answer because this is a difference of perfect squares. That's why I did a hint, hint, wink, wink, nudge, nudge. I can factor that some more. Difference of perfect squares, root plus root times root minus root. And now I am done. Okay. Keep going. 6x squared plus xy minus 15y squared. Is there a GCF? No. We are going to, it's not a perfect square trinomial either, so we're going to factor. Just ignore the variables, guys. Just ignore the variables. Okay, 6 times a negative 15. What is that? Negative 90. Factors of negative 90 that add up to a positive 1. Well, that's easy. 10 and negative 9. Okay, so I'm going to rewrite 6x squared plus 10xy minus 9xy minus 15y squared. Grouping. GCF, that would be 2x, leaving me with 3x plus 5y, minus 3y, leaving me with 3x plus 5y. A little bit tricky with the variables, but that's okay. So I have a 2x minus 3y times 3x plus 5y. And I cannot do anything with those, so it's factored completely. Okay. If you get to a problem like n and you get stressed out by that x minus 2, do a substitution. This is really the same thing as saying y squared minus 3y minus 40. There's nothing different between those two lines other than what y is equal to. Y is x minus 2 in our case, okay? So sometimes I do this. I do like a little substitution, all right? So now it's going to be easier for me to factor. I still look out for a GCF. I don't have it. I still check to see if it's a perfect square trinomial. It's not. So I go and factor. I need factors of negative 40 that add up to negative 3. Well, that's going to be a positive 5 and a negative 8. Because my a value is 1, I can go straight to my factors. X plus 5, and y plus 5, and y minus 8. I can't stop here, even though technically I'm done factoring, because I did a substitution. I said y was equal to x minus 2. So now I can plug that in, and this is really x minus 2 plus 5, and x minus 2 minus 8. And then simplifying, that's x plus 3 and x minus 10. And then that's it. Okay. All right, and let's do one more of factoring. 3x squared y squared minus 11xy plus 6. There is no GCF. It is not a perfect square trinomial, and so I factor. So I multiply 3 times 6, and I get 18, and I need factors of 18 that add up to a negative 11, and so that's going to be a negative 9 and a negative 2. 3x squared y squared minus 9xy minus 2xy plus 6. Group up, GCF, 3xy, xy minus 3, minus 2, xy minus 3. 3xy minus 2 times xy minus 3. Boom, boom, boom. I know I went kind of fast, like I said, but you have factored before. This should be coming back to your memory, all right? And so then the last thing we need to do is solve by factoring. So we're still factoring, but it's going to be equal to something. What we need to do is always set it equal to 0 first. Always, always, always. Most of the time it will always be, almost always set up that way, but it's not always going to be set up that way. So just set it equal to 0 and then factor. And then you set each factor equal to 0 and you're going to get 2 values of x for the most part. Sometimes you'll only get 1, and that's obviously when the vertex is on your x-axis, so it's just one x-intercept, one root, one zero. But most of the time, a quadratic does have two roots, two zeros, two x-intercepts. So here we go. Change colors. Solve by factoring. Well, first step is set it equal to 0. That's already done for us. Now it's like the quote-unquote factoring part, right? So go through your factoring thing. Is there a GCF? Is it a perfect square trinomial? Is it a difference of squares, etc., etc., etc.? So is there a GCF? Yes, it is 4x. So 4x times x minus 5 equals 0. That's it. I'm done factoring on the left-hand side. So I set each factor equal to 0. I have two factors, 4x and x minus 5. So that means x is going to be 0 or x is going to be 5. Here we go. Try it again. First step, set it equal to 0. I had to add 9 to both sides to get it equal to 0. Second step, factor. Is there a GCF? No. Is it a perfect square trinomial? Yes. The first term is a perfect square, the last term is a perfect square, and the middle term is 2 times the root of the first times the root of the last. So this is literally just x plus 3 squared equals 0. So how do I solve this now? Well, I'm solving for x. I am undoing PEMDAS. So I want to square root both sides. The square root of 0 is still 0, and then subtract the 3. So this is a scenario where there is only one root, which means that is my vertex. My vertex is on the x-axis. Set it equal to 0. So I'm subtracting 3 from both sides, so I get a positive 12, and that equals 0. Second step, factor. Is there a GCF? No. Is it a perfect square trinomial? No. So I just got to factor this. So I actually have to multiply 6 times 12, which is going to give me 72. So I need factors of 72 that add up to a negative 17, and that's going to be a negative 9 and a negative 8. And so I rewrite 6x squared minus 9x minus 8x plus 12 equals 0. Group up, find the GCF. GCF here is 3x. Oops. There we go. 2x minus 3. GCF here is a minus 4. And so my factors are 3x minus 4 and 2x minus 3. And so it's completely factored. So now I just set, now I just set each factor equal to 0. So 3x minus 4 is equal to 0, and 2x minus 3 is equal to 0. So that means 3x equals 4, which means x is 4/3, or 2x is equal to 3, making x equal to 3/2. And so those are my two values of x. And then we have one more. First step, make it equal to 0. Second step, factor. First step in factoring, find a GCF. I have one. It's x. Can I factor any further than that? No. So I set each factor equal to 0. So that means x equals 0 and 7x minus 10 equals 0, which means 7x is equal to 10, which means x is 10 over 7. And there you have it. Pretty easy if you know how to factor.